Hey guys, my 5-minute film is on solutions, so let's get started. A solution is a homogeneous mixture of two or more substances in one phase. It's made up of a solute, which is this in this case, and a solvent, which is this, which makes a solution. A solute is a substance dissolved in another substance, usually in the lower concentration, and a solvent is a substance that dissolves another substance in the higher concentration. An example of a solution would be salt water, where the solute would be salt and the solvent would be water. As you can see here, there are 3 steps to making a solution. The first step is expanding the solute, the second is expanding the solvent, and both of those are endothermic reactions. And then the third is mixing the two together to make a solution, and that's an exothermic reaction. There are 4 physical properties of solutions. The first is vapor pressure lowering, where the addition of a non-volatile solute lowers the vapor pressure of the liquid solvent, and you can see that in this picture here. Something to keep in mind for this is Raoult's law, where PA equals XA, P degree A, and PA is the vapor pressure of solution, XA is the mole fraction of the solvent, so how many moles of solvent there are over moles of solution, and P degree A is the vapor pressure of the pure solvent. And another thing to remember is PA plus PB equals P total, where the vapor pressure of A and the vapor pressure of B is the vapor pressure of the whole solution. There are 2 physical properties that are really similar, freezing point depression and boiling point elevation. Freezing point depression is the addition of a non-volatile solute lowers the freezing point, and the equation that goes with that is delta TF equals KFIM, or delta T equals Chem. And boiling point elevation, the addition of a non-volatile solute raises the boiling point of the solvent, and that's basically the same equation. So delta TFB equals the change in temp, so the change in boiling or freezing point. KF and FB are the freezing point or boiling point constants, and you're usually given these either in the problem, and if you're not given them, then you're probably solving for them. I is the Van Hoff factor, which is the number of particles a compound dissociates into, and if they don't tell you what it is, just assume it's 1 for the most part. Things like organic compounds will be 1 because they stay together, but things like sodium chloride will be I equals 2 because it splits in solution into Na plus and Cl minus, so just keep that in mind. M equals molality, which is the moles of solute over kilograms of solvent. The 4th physical property of solutions is osmotic pressure, where the minimum pressure required, which is the minimum pressure required to stop osmosis. Osmosis is the flow of solvent through a semi-permeable membrane, which is where only water can go through it. There are 3 things to keep in mind here. First is isotonic, which is where it's the same pressure and concentration inside and outside of the cell. Then there's hypertonic, which is where there's a higher osmotic pressure inside the cell, so it pushes out the water. It pushes out the water, causing a higher concentration in the cell and causing the cell to shrink, as you can see here. And finally, there's hypotonic, which is the opposite, where it's lower osmotic pressure. It takes in water and causes a lower concentration in cell, which causes it to swell and even burst sometimes, like you can see here. Alright, we're going to do 2 quick practice problems. So the first one says, a solution containing 3.23 grams of an unknown compound dissolved in 100 grams of water freezes at negative 0.97 degrees Celsius. The solution does not conduct electricity, so it's non-electrolytic. Calculate the molecular weight of the compound. The mole freezing point depression constant for water is 1.86 degrees Celsius kilograms per mole. So that is our KF. So then you plug it into the delta T equals Chem for freezing point, and you plug in all your values you get. You assume that I equals 1 because it doesn't tell you what it is. And since the only thing you have left is molality, you know that you're solving for that. So you do 0.97 divided by 1.86 divided by 1, get 0.521, and you know your units are mole solute over kilograms of H2O. You know that you have 0.1 kilogram of water because it says you have 100 grams of water. So you multiply 0.521 by 0.1 and you get this many moles of solute. You know you have 3.23 grams of solution, so you take that, divide it by the moles you have, and you get 62 grams per mole is your molecular weight. The final problem says alcohol dissolves in water to give a solution that boils at a lower temperature than pure water. Salt dissolves in water to give a solution that boils at a higher temperature than pure water. Explain these facts from the standpoint of vapor pressure. A solution of alcohol in water has a higher vapor pressure than pure water because alcohol is a volatile solute, and since it's volatile, that means it increases the vapor pressure. The higher the vapor pressure, the lower the boiling point. A solution of salt in water has a lower vapor pressure than pure water because salt is a non-volatile solute. This decreases the vapor pressure because it's non-volatile, and we discussed this earlier. And the lower the vapor pressure, the higher the boiling point. Alright guys, that's about it. Thanks for watching.